Hey guys, welcome back to the channel. It's me, Shiwo. Today we will explain how to graph motion. Motion is essentially the change in position of an object away from its starting point. Motion may come off as challenging to graph, but it can be easily represented through distance versus time graphs and other methods. Note that time is always the x-axis as it is the independent variable.
Now, distance versus time graphs can tell one a lot about what is happening. Just a little example. So let's suppose we have, a slope which has a value of 0. That means that the object in question is not moving at all. Now, if, let's say, the slope was actually negative, then that means that the velocity and the displacement will move in the negative direction. And in case you guys forgot, velocity is the rate at which an object changes its position, whereas displacement is how far the object is from its original position.
Now we will go over two example motion graphing problems I have created. Okay, so this is question 1. Essentially, Shiraz buys a new car. When started up, it steadily accelerates at 3 meters per second squared for 10 seconds, starting at an initial velocity of 0 meters per second. What position does the car reach in this time? In other words, how far does it travel? So to recap, the given info we have is time equals 10 seconds, original velocity equals 0 meters per second, acceleration equals 3 meters per second squared, and we're going to let the distance be d. When solving for distance, we use the equation d equals VOT plus half AT squared. The variable that we're trying to find, which is d, is already isolated, so we can carry on and substitute the numbers and units before solving. So as you see, we solve it. D equals 0 meters per second times 10 seconds plus half of 3 meters per second squared times 10 seconds squared, which leads to d equals 0 meters plus 15 meters, and finally d equals 15 meters. And we're going to leave it as 15 because we are using two significant figures, as all the values provided are in two significant figures at least. Now we're going to double check the units. So basically we're going to take the same equation we were using, except get rid of all the numbers and keep only the units. And as we can see here, it results in distance equals meters. So distance is measured in meters. So then we know the units are correct. So as for our final answer, the car travels 15 meters. That's the distance. And that's essentially the position the car reaches in 10 seconds.
Okay.
Just a quick note, this problem involved is solving for distance. In other cases, we may need to solve for acceleration, time, or other components of the situation. In those scenarios, you simply need to restructure the equation to isolate the variable before plugging in your values. And that's the full question.
So now we move on to the next question, which entails Wasay and James are wrestlers getting ready to charge at each other at a fighting event. They are 20 meters apart. They both start running towards each other at the same time, except Wasay is running at 2 meters per second, and James is running at 3 meters per second. They reach certain positions at certain times, all of which are provided in this question. The y-intercept of each line has also been provided. Now we need to calculate they will meet as well as the slope of each line. So first, what is our given info? We have the distance between Wasay and James, which is 20 meters. Wasay's running speed, which is 2 meters per second. James's running speed, which is 3 meters per second. Wasay's y-intercept, which is 0 to 0. And James' y-intercept, which is 0 to 20. Now, over here we have a table which corresponds to each value given in the time column. So 0 corresponds to 0 and 20. 1 corresponds to 2, 17, and so on and so forth. Now, looking at this data, we can see that if we let t represent time in seconds and d represent position in meters, the following equations are true. James's equation would be d equals 20 minus 3t, and Watson's equation would be d equals 2t. Although we do not technically need these equations in this problem, using this method could prove, useful when few reports are provided. So firstly, let's find the slope of each line. We can use slope-intercept form because both lines are straight or linear. We know this because both Wasay and James are moving at a set pace and not accelerating or slowing down at any point. So right here we have the equation y equals mx plus b, And now we just insert our values, which would be 6 equals m bracket 3 plus 0, which would give us 3m, and then which would give us 6, m equals 3. Now again, we have y equals mx plus b. We have 11 equals m bracket 3 plus 20. We have 3 equals 11 minus 20, which would give us negative 3. Because, when you subtract 11 from 20 from 11, that would give you negative 9. Divide both sides by 3. You have your answer. Now, it's time to find out when Wasay and James will meet. To do this, we can either graph and look at when the lines intersect, or simply continue the table until they are at the same position. So if we see here, Wasay and James will meet in 4 seconds. Now the final answers we can draw from this question. Wasay's slope will be 3 meters per second. James's slope will be minus 3 meters per second. And Wasay and James will meet in 4 seconds. Now, as we can see, the two velocities, they make sense because we're coming from the opposite direction.
These two problems are extremely common in the Physics 11 course. So the only logical thing left to do is to review them. And with that being said, I'll see you guys later. Take care and bye.
Thanks for watching and peace out.